Topping the charts, 57.4% of all data jobs demand SQL. It's in high demand because, well, so many companies use it. So if you want a job working data, you need SQL. Hi, I'm Charu, a technical trainer at SAS Institute. Welcome to my virtual dinner party. In today's video, I'll be sharing the power of SQL in record time. To be clear, learning SQL can be a bit daunting. I'll make it fun by analyzing dinner data. We'll explore the relationship and ask interesting questions like, what's the relationship between spice and fat? Wouldn't you like to know that one? Stick around to the end. As your hostess with the mostest, I'll reveal all this and much more in this Power of SQL video. I personally believe that knowing SQL is one of the most important skills for data workers. I'm not going to share generic tips. You already got that. I'll be sharing 3 specific tips to harness the power of SQL in SAS. First, I'll show you how to craft an efficient SQL query. Next, I'll show you how to join a table 3 ways. Hint, it's not what you think. Lastly, I'll show you how to store a query in a macro. My guests are here. My ladle is ready. What are we waiting for? Let's get cooking in the power of SAS SQL.
Now let's say hello to the chefs and their dishes. Everyone has chickpea in their pantry, but the difference is in the twist. Each of us is going to come up with a chickpea dish that is unique and completely different from the others. Pema is making a Bhutan chickpea stew. I'm making chana masala. Tomas decided to make a Portuguese chickpea salad. Troy is bringing a chickpea tuna salad. Mataya wants to try Spanish carded chickpeas. Gigi is bringing a leblebi Moroccan stew. Chiquita is making chickpea tacos. Noah is bringing za'atar chickpeas. Hasn't that got you excited about the party?
Now that we know who the chefs are and the dishes they're bringing, we'd like to get to know a little bit more about the data. Here's an entity relationship diagram, which is basically the relationship between the tables. I have 3 tables. The first is the chef table. 8 rows of data, 8 unique recipes, 8 unique chefs. 4 columns, the name of the chef, the country of origin for the recipe, a link should you wish to try the recipe at a later point, and the name of the dish itself. In the ingredients table, I have details about the ingredients. I have columns such as liquid, it could be water, the name of the dish, and then for those who are interested in heart healthy recipes, there's a column called oil and tablespoon. An interesting column called spice quotient, which we'll keep a close eye on in the next few slides. And then there's a column called vegan, for those who wish to experiment with plant-based dishes. This is a binary column, which really means it can have one of 2 values, yes or no, a 1 or a 0. The last table carries detail about the spices. When you look at columns spice 1 to spice 7, it might come as a bit of a shocker. But don't be intimidated. These are just names of the spices. And much like weather, if you're curious, spices also have sometimes a heating quality, sometimes a cooling quality, and sometimes they may even have a bitter quality. So those are the names of the spices. Further down, there is a column called spicy, which also carries a value of either yes or no, also a binary column. Now let's look at the relationships themselves or commonality to complete this entity relationship diagram. Between these 2 tables, the common key or the common column is called name in the chef table. It's called recipe name in the spices table. Now this is quite an interesting surprise, isn't it? That SQL is able to see commonality even though the names of the columns are different. More on this when we get to section 2 on joins. Between the remaining 2 tables, the common column is name, and these indeed carry the same column name. Now let's step back here for a second and try to understand why we even spend time in drawing out an entity relationship diagram. What is the purpose of it? And the answer lies in the number one rule for all data workers. If you guessed know thy data, you are 100% correct. Know thy data has to be the most important principle before we begin diving into data analysis and data reporting. We need to know the names, types, lengths of the columns. We need to know the common columns between the tables before we can attempt to get further in our data analysis work. And that's the purpose of drawing out and mapping an entity relationship diagram. Let's take a look at a couple of other things. Here's the chef table with its 8 rows of data, 8 unique chefs, 8 unique recipes or dishes. Then I have a spice quotient table. This came from the ingredients table. This column called spice quotient can have a value of, for example, insanity followed by a number. And that number is indicative of how hot this spice is. So later we'll show you how to filter through this column and subset and get only those dishes that match the spice quotient that you are interested in. The choice is clear, so many dishes and so little time. Let's dive into learning the power of SQL in section 1. In this first section, we're going to learn to craft an efficient query. Much like humans in our interactions, where we have a certain order in which we phrase a request, SQL is no different. Visualize for yourself for a second a call center. You make a call and you are directed through a series of questions that the call center specialist asks you to elicit response. SQL is no different. It expects you to ask your questions or queries in a certain order. So let's examine that syntax order. The first statement, and the biggest of all of these in a SQL query, is called the select. On the select is where we are going to place each of the columns that we wish to appear in the final result. Below the select is a number of smaller statements called clauses. These are the building blocks. And here is the from clause. On the from clause, we are going to list the tables that we want to extract the data from. So I would like to pause here for a second and mention that 2 things are mandatory in a query. SQL expects you to provide the select and the from. And so the questions we provide in the select is what do you want? And in the from, where do you want it from? So these 2 statements are mandatory. Next is the where clause. Here is where, a very powerful clause, where we can subset the data. Then we have the group by. Pretty self-evident by the name, it allows us to group the data. The having allows us to filter the group data. And the order by allows me to put an order of the columns that appear on the select. So I'm not sure about everybody else, but I definitely feel that knowing a few human languages, knowing a few computer languages certainly makes remembering things a little bit more challenging. So here is a mnemonic to remember the order of statements. So few workers go home on time. If you are a brand new SQL user, this might be handy. If you have already been using SQL, then I'd appreciate hearing from you with a comment down below on the mnemonic that you have used in order to make your SQL remembering super easy. Here is my library already assigned. It's pointing to a location on my C drive. I have 3 data sets again. As a reminder, our data sets are the ingredients data set, the chef data set, and the spices data set. So in order to take a look very beginning, very fundamental at the rows and columns in the ingredients data set, we'll provide 2 statements. We'll invoke procSQL and then a semicolon, and then we'll submit the select statement and the from statement. On the select statement, we are going to add an asterisk, which is a wildcard for saying, give me all the columns on the ingredients data set. In the from clause, we are going to give the name of the table, which is the ingredients table in the dinner library. Above the procSQL statement, I have a title statement. This is global, so I can stick it anywhere in my code. And because it actually corresponds to the SQL query right below it, it makes sense to stick the title just before my SQL step. So you'll notice that the select is like one big paragraph that ends in a semicolon, and this is SQL. So SQL says, as soon as I see the semicolon, I'm going to instantly execute the query. So this might also make sense why we did not introduce the title statement below the proc SQL step, because once the query is over and done, it's already executed and it's printed the results in the results window. There is no point having a title statement after that because this query is finished. So that's the position of the title statement. The quit tells SQL, I'd like you to leave memory, and if you didn't leave the quit, then what you could do is execute more queries, some more subsequent queries. But we'll keep it basic and simple. We'll go ahead and execute this query so that we can see the rows and columns in the ingredients dataset. So here it is, a full look at the ingredients dataset. 8 rows and all the columns plus their values. So if you had a lot of data, it would be really difficult to scroll through. If you had, for example, 1,000,000 rows, it would be virtually impossible for you to know how many rows there are. So there's a couple of options that can help me. I'll head back to the code and show you this really clever macro option. With the %put statement, I'm telling SAS, please go ahead and give me the value of this macro variable SQL OBS. So SQL OBS is basically saying, give me the number of rows that this query returned. So I'll submit this. And chances are when I look at my log, I do see the number 8, but it's kind of hidden among the column numberings. So it's not super clear to me. What I like to do instead is perhaps add a bit of text and ask SQL to give me the number of rows this way. So there's a piece of text and then after that followed by the macro variable. Now this makes it so much easier to check out in the log. What we saw is an asterisk which was basically give me all the columns in this table. And if we look at the columns in the table, we'll need to rerun the query. We have some interesting columns here. We have the name of the dish. Then I'm also curious about the oil and tablespoon column as well as the spice quotient. So if I want just those 3 columns, on the select, I'm just going to list those 3 columns separated by a comma. And I want to list these columns in the order in which I want them to print in the results window. This now is going to give me the exact same number of. Heading back to the code, once again verifying that I'm going to list the columns in the order in which I wish to see them. And indeed, I got exactly what I wanted. Now that's the beginning, the introduction of 2 statements, the select and the from, 2 mandatory statements. Now let's move a little further into our code and let's see if we can subset the data. For example, we are working from home and we might have started becoming more conscious of heart-healthy food choices. So how can we subset the data? Here is the where clause. It is one of the most powerful clauses in the language of SQL. In fact, it also makes its appearance in the SAS data step and other SAS procedures as the where statement. Essentially, it operates in a very similar manner. It needs something that you're asking for, the column that I'm requesting. And then on the right side, it needs a value. And in between, it needs some kind of comparison operator. So here, I'm curious to see which of my dinners are low fat. And so that's why I have the where clause. Is the order of statements important? Yes, the order of syntax is super important to SQL. And did I say SQL? Sometimes you'll hear this interchangeably, SQL, SQL, and they both are exactly the same. So we have a select asterisk again. On the from clause, I put my ingredients table. On the where clause, I'm asking for only those rows that meet a certain condition. My condition could have been anything. Thing to remember about the where clause is that it needs you to act on existing columns. And what does that mean? An existing column is a column that is appearing from a table on the from clause. A calculated column would be something that you built in the query. And there are some workarounds around it, but for this purpose of this presentation, suffice to say the where clause acts on existing columns. Oil and tablespoon is an existing column. The other thing to remember about the where clause is like has to match like. If the column on the left side is numeric in nature, any comparison data value, which is 3, needs to also be a number. However, if we had queried a character column, a comparison on the right side needs to be for character data. Pretty simple, like has to match like. That is rule number 2 with the where. And the first rule was I need to subset on existing columns. Here, I'm going to submit this code and I already have a percent put. I called it number, but we can go back and call it rows. We can call it whatever our heart desires. It's a text value. So how many rows am I going to get for dinners which are low fat? We let the where clause examine this. Returns for me 2 rows of data. So these are the 2 dishes that have low fat, relatively low fat compared to the rest of my dishes. I'll also go back to the log and I'll see the number of rows is 2. You might question the value of this percent put statement here when you could easily see the 2 rows of data. So I'm here to show you not just how you can work with this smaller, simpler data set, which is easy to learn from, but also how to apply it to your millions of rows of data. Chances are, in your work environment, the number of rows is far more than what I'm able to show you on the screen. So this percent put statement comes in super handy then. Heading back to the code, up until now, all we have done is learn 3 clauses: the select, the from, and the where. And right now, all we've seen is rows and rows of detailed data. We really have to get summarizing the data so that we can boil this down and answer some really interesting business questions. So we would like to introduce you now to the concept of grouping. The concept of grouping is one of the most important tasks that you have to deal with while working with databases. To group data, you use the group by clause. And let's say you wanted to know the average fat in dishes and you want to see the data summarized by spice quotient. You want to ask a business question here, and that is, does fat really help with reducing spice? You want to let the data tell the story. So that is the group by clause which we'll use here. It's an optional clause in the select. It combines rows into groups and it summarizes data. Oftentimes we use the group by combined with an aggregate function like min, max, average, sum, or count to calculate a measure. Let's go back to a business scenario and take a look at the last result we obtained. We had requested 3 columns from the ingredients table and we had filtered the data to look at the oil in tablespoon. In this example here, I'm not filtering the data. I'm just seeing 3 columns appear in the ingredients table. I'm seeing all 8 rows. Now, if I want to see these rows grouped by spice quotient, then it would look something like this. We'll take a look at the endorphin rush spice quotient. That is going to get summarized to a single row. And then we're going to add up the oil in tablespoon And because there were 2 rows in endorphin rush, 6 divided by 2 gives me a 3. Further down below, I have 2 more rows in spice quotient with the same value. This is a value of sweet. So again, the summarizing gives me an average oil for this spice quotient for 4. So here is a beautiful way to see, does fat really help with reducing spice? And you can see how some of the spice quotients, for example, slow kick, has quite a high portion of average oil. So perhaps you can make some decisions on, maybe I can reduce the amount of oil because this is not a very spicy dish, assuming I'm looking for low spice. And for the top endorphin rush, perhaps the average oil is okay. Insanity has an average oil of 4. Maybe I can up the oil and customize my dish. Let's go back to the earlier question we posed. And let's say we want to know the average fat in dishes and you want to see the data summarized by spice quotient. Here's my SQL query. On this select, I have to list the columns that I wish to see. My first column is spice quotient. That is my group by column. And the second column is my summary statistic column. Here, I want to take oil in tablespoon and get the average for each value of spice quotient. I've also given a label for this column because if I omitted that label, then I'm going to get a report with no header for this second column. And I do want to make my report meaningful. On the from clause, I list the ingredients table. Then I have my group by. Spice quotient is my grouping column. And here we have the results and we can see the average fat content for each level of spice quotient using the group by. So I just showed you how to use the group by clause to summarize rows into groups and apply the aggregate function of average oil in tablespoon to each group. Why is this useful for our chefs? Well, a little known secret that chefs use is that the heat of spice can also be counteracted with a bit of fat, liquid, or dairy. All spices are fat soluble. So the addition of a healthy oil like grapeseed, olive oil, or coconut will help dissolve and dilute its spicy molecules. So our chefs can put that tip to good use and they can modify their recipes or even provide a modification for those who wish to use it. So let's put that principle into action. Let's head back and try to filter now and get only those rows which have a certain average oil value. So we are going to subset the grouped data. We receive fewer rows and we still want to boil those rows further down. And in order to do that, there is a new statement being introduced. Let's look at the code here. We really have made no change other than the introduction of a new statement, a new clause that's going to filter my data. But wait, didn't we say earlier that the where clause is one of the most powerful statements to filter the data? How come I did not use a where clause? Well, let's then use a where clause. Here we have on the select the columns we wish. On the from, the table we need, the group by is grouping our rows. And now we've said where AVG oil and this operator is greater than or equal to 4. And there are a few red messages in the log. And the very first message is to do with the where clause. In the log, I see an underline with red and there's lots and lots of red there. And so I also end up getting a syntax error. So probably because I did not put the where clause in the right place. If I remember the order of statements, I needed to have the where right after the from. So I'll just move that where clause and give this a go again. Now you have a very interesting error in the log. You still have an error. The where clause did not work. And SAS comes back to you and to tell you the following columns were not found in the contributing tables. AVG oil. Do you remember the two things we spoke about the where clause? One was it has to work on columns that are on existing tables. For SQL, existing means anything that is on the from clause. So AVG oil did not exist in the ingredients table. It was actually built on the select statement. So the where clause has no access to this column, and therefore it choked. So we're going to have to head back and make a modification. We're going to move this where clause from here. Clearly, it's not going to work. And we are going to add in place of the where, the having. So this is the clause that's going to let me cut through my grouped data. Let's pause here for a minute and just review this powerful concept. The where versus the having. The where clause acts on existing data, on detailed rows of data. The having acts on grouped data. So the difference, if you were to imagine a grocery analogy, is going to the grocery store and buying your apples. You bring them home in their raw form. How you treat them and how you cut them is quite different if I decided instead to make apple pie. The treatment of the apple pie is quite different from the treatment of my raw apples. So the where clause is like the knife you would use to cut your raw apples. It hasn't been transformed. It hasn't been processed. The having is the way you would treat your apple pie and the way you would cut it. It's completely processed. It has no resemblance to the original apples. And that's a distinction I wanted you to take away. The difference between the where and the having. The where acts on detailed data, on unprocessed data, on the original rows. And the having acts on your summarized data. It's able to cut through and filter your summarized data. So here we have the having. I'll submit. And there we go. These are the 4 spice quotients that have an average oil value of greater than or equal to 4. Using the having clause, we were able to effectively cut through the group data and grab only those rows that met our condition. Adding to our building blocks now, we would like to see the results ordered in a certain way. So while the results gave us the average oil, it's not really ordered in a manner which makes it easy on the eye. A nice order might be, well, show me the results in order of descending average oil or ascending average oil so that I can make some calculated decisions. To add to this is the order by clause. Here's the business question I want to ask. What spice quotients have the maximum amount of fat? So the query hasn't really changed. We're still selecting spice quotient, summarizing average oil in tablespoon. From the ingredients data set, we are grouping by spice quotient. We use the having clause to cut through and get only those rows where the summarized column average oil is less than or equal to 4. To add the order by statement, which is the last statement in our query, I just stick it there after the having. Interesting ways in which I can use the order by. I can either list the column name from the select. Now it so happens that the column name has an alias here. This is very handy. If I didn't have an alias for this new column name, guess what? I would have to retype AVG brackets oil in tablespoon every single time I needed to reuse it in my query. But I'm still, not that big a fan of typing so much. I think I'm a smart programmer. So I want to reduce the amount of typing I do. And the order by gives me a possibility. It says, you don't have to type in column names. You can even type in an integer value representing the column position of that column on the select. So let's back up there. Long statement. I want the column position on the select happens to be the second column. So I stick order by 2 in descending order. So again, I'm trying to see the results to see what spice quotients have the maximum amount of fat using the order by. And this gives me a descending order. So I can see recipes and dishes that use the most fat and try to correlate in my brain the spice quotient and make important decisions about, if spice quotient of sweet has an average oil of 4, can I dummy down the amount of oil? Can I maybe reduce the oil there? Because the recipe is already sweet and it looks like fat can counteract spice. So it's not needed as much in this for that recipe. Further down, if I have insanity using 4 tablespoons of oil, perhaps I can up the amount of oil if I'm not so keen on a very hot dish. Let's do a quick recap of section 1 on crafting an efficient query. These are the statements that SQL needs and in this order. 2 things that are always mandatory are the select and the from. Everything else is optional. Let's move on to section 2. Join subqueries, inline views. 3 ways in which I'm going to show you how to grow your table wide, because that's basically what a join is. Stacking your tables beside each other to grow them wide. Let's understand the concept of an inner join. I have my chef table and my spices table. So why do I need data from both the data sets? Well, the chef table has the names of the chef, and the spices table has information about the spice ingredients. And I really want to strike a midway mark. I want to find those chefs that are going to make dishes that are kind of a moderate heat rating, about a number 3. So I'm going to basically stack these tables beside each other in an inner join and provide a condition that says, give me those rows where the heat rating is less than or equal to 3. And that condition is really important for a join. If I didn't put a condition in, then SQL is going to take the 2 data sets, slap them together, and give you all possible combinations. And that is called a Cartesian product. And we don't want to be building that monster. So we are using an inner join. So that's conceptually the idea of an inner join. You can replicate the same action that an inner join does, which is growing the data wide, through a subquery. Here is a list of recipes or dishes that are low in heat. And this is going to be my subquery. This data is coming from the spices table. I'm going to pass this list to the outer query to match it up and see which are the chefs that are making these dishes. So the outer query is going to be the chef table. Under the covers, SQL may decide to do a join while you provide a subquery and a query on the outside. But the concept is basically the same. You're growing the data wide by grabbing more information. Best practices for a subquery indicate that the subquery must be standalone, must be independent. So you really want the subquery to provide values to the outer query. And this is called a non-correlated subquery. You don't want the outer query to pass values to the inner query. That becomes a correlated subquery. It can be messy and it can lead to a very expensive query which runs over days, perhaps weeks. We saw the concept of a join. Now how does it play out in code? Here is the syntax. On the select, I'm going to list all the columns from all the tables that I'm grabbing on the from. For the first time now we are seeing on the from clause 2 tables listed. The chef table and the spices table. And we stack them together using the inner join syntax. And that's not all. We need to supply the join condition. That goes on the on clause, where you specify the table name followed by the column name, chef.name equals spices.recipe name. So that is your inner join. And then to that, we also want to filter through those rows of stacked data. We want to grab only those rows where heat scale is less than or equal to 3. We're kind of hitting that moderate heat mark. And so these are the chefs and these are their recipes. So what I'm seeing here is amazingly useful. On the left side, the first 4 columns are coming from the left table, the chef table. The remaining columns are coming from the spices table. So you have a lot of information and a lot of possibilities to mix and match. A thought struck me though as I was writing this code. I had to spell out chef.name on the on clause and spices.recipe name. And I already mentioned I believe in being a smart programmer. So how can I modify this program to make it a little smarter is by providing aliases. We saw aliases in section 1 for column names. Well, we can certainly apply aliases to table names as well. And you can make it as short as a single character. So dinner.chef going forward as C provides SQL the information that anytime I use column from this table, I am going to qualify it with C.name. So it does 2 things here for me, this handy little tip. Firstly, it reduces typing, which as we all aware, we're all trying to minimize. Secondly, if the same column name sits on both the tables, and of course here it's not a problem because the chef table has a column called name, the spices table has a column called recipe name, so here it wasn't a big problem. But assume that the same column exists in multiple tables and we want to join by those same columns. Then I would need to provide a qualifier. And in that event, the qualifier, which is short and sweet, makes a lot more sense. Is this query going to give me the same results? We'll take a look. And indeed, I'm getting the exact same results. So question of a join would be incomplete if I did not mention efficiency. And I'm going to show you an alternative way of crafting your inner join by using the where clause. So I'm again going to stick those aliases, dinner.chef as C, dinner.spices as S, so that I can scrap this lengthy name. S.name equals, C.name equals S.recipe name. What was the difference in this code? The alternate syntax no longer uses the inner join words or keywords. It separates the 2 tables with a comma. And then in place of the on clause, you use the where clause to provide not only any filter that you need, but also any join condition. So that works, does it? We'll take a look. And the results are exactly the same. The difference is the efficiency. And here I'm going to enter the space of the logical query processing order. Up until now in section 1, you learned the syntax order and you knew how to respect the syntax of SQL. But now we look at the logical query processing order. And that means this is the way SQL processes your query and actually does the work under the covers. Surprise, it's not going to do the work in the order in which it asks you to speak to SQL. It's going to do it in a completely different manner. So one of the first things that SQL will tackle in this logical query processing order is the from clause. So the from clause is the first processing. And then it's going to tackle the where clause. So if we look at the inner join where we use the on clause, can you see where there's a little efficiency boost by using the on clause? Because the on clause is really part of the from, whereas the where is the next statement. So that's something to bear in mind as you craft your query in the difference between the where and the on. That's one difference. The second difference is when I use a where clause, and here in this example, I only have 2 tables. What if I had 20 tables? Or maybe 30 tables? My where condition becomes very complex, and I have to make sure I provide all of the join conditions correctly. If I leave it out, I might end up with a Cartesian product. So those are the 2 reasons why you might want to head over and use the on clause for providing your join condition. Before we dive into code to look at the subquery, it would be a nice reminder to look once again about the concept of a subquery and how it plays out. So I'd like to show you 2 visuals here. The first one is about the tables themselves. Here is a spices table, and the business question is, what dishes have a moderate heat rating which is less than or equal to 3? This column heat scale exists in the spices table. So that's the one we are going to tackle. We're going to grab rows from the spices table where that heat scale is less than or equal to 3. The rows that get returned need a purpose, need somewhere to go. And the only reason we are grabbing these rows is that so that we can see the chefs that correspond to this moderate heat rating. So we can ask them more questions about their dishes. So those rows are passed to the chef table. And so there's a match between the recipe name on the spices table and the name on the chef table. Let's take another look at the visuals. So the rows that are returned are these. And this is the recipe name. And this would be the subquery. We're grabbing rows from the spices table. Once these rows are returned, based on my where clause, I'll pass these rows to the chef table so that now I can get the names of the chef, the country of recipe origin, the link from the chef table. So you can almost visualize that it is like a join, but we are crafting it as a subquery. Let's head over to our SAS session and see this play out in code. We like to grab those rows that have a moderate heat rating from the spices table. So the moderate heat rating is where heat scale is less than or equal to 3. So my inner query or my subquery will return me the rows that have this heat rating. And that's 6 rows of data. Now I've got to pass these rows to the chef table so that I know the names of the chefs and I can contact them for more information. So in order to do that, I'm going to have to copy these values from the results window and go back and plunk it in code. Let's examine what looks like complicated code and break it down. We are selecting all the columns, select asterisk, from the chef table, but we don't want all the rows, so we have a where clause, and we qualify the rows we want to return based on a condition. That condition is where name is one of a list. And here is where we type in the list that was actually returned, if you recall, from the previous subquery. What am I going to get when I submit this query? I'll get the names of the dishes as well as the chef's names that give me the detail I was looking for. Now this is a lot of manual intervention, and if you recall, my favorite task is not spending time doing this work. If I go back to my code, I'll explain why. Firstly, anytime data values change, I need to rerun my subquery first, head over to the results window, copy those values and paste them here. There is a lot of manual intervention going on, and the minute human intervention enters, I know I'm prone to error. So let's see how we can craft this query in a slightly smarter way. We are going to take the entire subquery and just paste it instead of pasting the data values. Job well done. So the exact same query, no change. The only change is taking my subquery and pasting it where earlier I was pasting data values. Submit and see if we get the same results. And the results are exactly the same. So there we go. We learned a second way of joining our tables, growing it wide, and also made it very efficient. This type of subquery is called a non-correlated subquery. And how do I know that this is a non-correlated subquery? And is it best practice? Are probably a couple of questions you might be thinking about. Yes, a non-correlated generally is best practice. And how do I know? Second question, how do I know if it is a non-correlated subquery? I'll head back and look at my inner query. And that inner query must not be dependent on the outer query to supply values. In fact, it's an inside-out query. The inner query is what is supplying values to the outer queries for a match. Right? Same here. The inner query is supplying data values to match with the outer table. So that's an example of best practices in a non-correlated subquery. And these were two ways of growing the data wide. Possibly you've worked with joins, inner joins. Possibly you work with subqueries. But it's also possible that perhaps it didn't strike us that these are both techniques to grow the data wide. But I'm not going to stop here. I'm going to share one more technique to grow the data wide. And this technique is called an inline view. Now, the minute anyone hears the word inline view, chances are they start thinking that this is a view. But you are smart. You're not going to think that way because I'm going to share with you exactly what an inline view is. It is not a view. So we've already set the record straight on that. What it really is a query that is going to sit on your from clause. So if you rewind and you think about what goes in the from clause, well, tables go in the from clause. So if I replace a table with the query, what is that doing? Basically, it's creating an intermediate table. And that you can join with another table. So in effect, it is like an inner join. And if the inline view is basically a query on the from, it acts like an intermediate table. So in this code here, I am grabbing rows from dinner.spices where heat scale is less than or equal to 3. Combining it with a physical table. How interesting is that? A virtual table is being combined with a physical table. And because it's being combined, it becomes an inner join here. And I need to specify a join condition. So back up here a second. If I don't specify the join condition, then I'm going to end in a Cartesian product. Even though it's a virtual table, I still need to specify the join condition. Table is a table at the end of a day, virtual or physical, in terms of SQL. Having this inline view in place, are my results going to be any different versus the subquery versus the inner join? And the answer is no. I get the exact same results. In my code, I just want to point out one other factor. Here, the names of the columns are different. So they did not need to be qualified. You know, SQL says you can always use the same name column for joins, even if they come from two data sets. I don't care. The only thing is, if they have the same name, please tell me what table they come from. Here in our example, the names are different in the two tables. So we don't need to qualify them. But if they were the same, then you would need to qualify them like so. You would need to give an alias for the first table, and you would need to give an alias for the second table, and then on the where clause, you would specify the join condition using the table qualifier. Once again, recap, only if you had the table names, the tables with the same column names. In our example, it wasn't a problem. The two tables had different column names, so it never even entered into our consciousness. So there you go. You have 3 techniques to grow the data wide. We learned an inner join, we learned how to craft a subquery, and we learned an inline view, as well as best practices throughout in learning the power of SQL. The SAS macro language allows us to create variables that we can use over and over again. In my third and final Power of SAS SQL tip, I'll show you a cool way to store a SQL query result in a macro. So we are really combining the power of 2 powerful languages, the macro language and SQL, so that once the query result is stored in a macro, I can use it over and over again. Let's take a look at the syntax. Select, you provide the name of the column, and then the into clause, colon, creates the name of the macro variable, and then the from clause provides the table name. Pretty simple. The only addition was the into clause. How about a business example? Well, let's consider I'd like to see which of my dishes among all of the 8 dishes have a heat rating that is less than the average for all the dishes. Here's the code. Select AVG heat scale into colon AVG heat from dinner.spices. So that average value that I calculated is now being stored in a macro variable called AVG heat. And that I can use over and over again. I can plug it in my title statement. I can stick it in a where clause. I can use it in multiple occasions. So that was step 1, creating the macro. Step 2, we want to use this macro. Wasn't that the purpose of creation? And here's how I'll use it. A standard query. Select everything from dinner.spices where heat scale is less than that macro variable. How do you tell SAS it's a macro variable? You insert an amper before the name of the variable, so SAS is able to make the distinction and see this as a macro variable, not just a regular variable. So a couple of other things to bear in mind when you're building these queries that are stored in a macro and you want to use that macro. Firstly, that where clause principle, like has to match like. If I'm comparing for a numeric column like heat scale, the comparison on the right side should be a numeric value. And how does SAS know that this is numeric? And what about quotations? Well, if my original code used quotations and I want to replace that value with a macro, then I must use double quotations. Here, let's take a look at this example. Heat scale was numeric. I would have typically said less than 2.25 if I was hard coding that value. Since I'm replacing it with a macro, I don't need quotations because what was the principle? If the original code used quotations and I want to use a macro, then I replace that with double quotes. Now, if my original code was a text or a character value like recipe name, and I want to compare with a data value that's character, then I must include the macro in double quotes. So let's take it to code now. And by the way, these are the dishes that have a heat scale less than the average for the entire set of dishes. Let's see this play out in code. Which recipes have a moderate heat scale? Now I have no idea at this time what is a moderate number. So I'm going to target somewhere in the middle and I'm going to say give me all rows where heat scale is less than or equal to 3 and grab the data from the spices table. So this query is going to result in 6 rows of data. 6 dishes have a heat scale less than or equal to 3. Now that was all fine, but was that truly hitting the average mark? I was guesstimating, so to get to a true average, I need to go and grab this from the data itself by passing the average function to this query. So what is the average heat scale? And then I can use that average to grab rows of data that kind of match the average. And the average is going to be 2.25. I'll copy this over and then I'll bring it back to code to paste it in the space where I'm asking for heat scale less than the average. Earlier I had supplied less than or equal to 3. Now I am going to the actual average. And that gives me those 5 rows of data. Up until now, we have not done any macroizing of our code. We've been hard coding this value. The practical use of the macro is reduce, reuse, recycle. So first up, I'm going to select the average of heat scale, and I'm going to store it into, isn't the SQL language so similar to the English language? Store it into a macro variable. So into followed by a colon, and then the name of the macro variable. What is the name? It can be user defined. Can it be anything? Well, anything as in acceptable by Sass meaning rows. And I've also turned the no print option on because this is a single value that I want stored in a macro variable. There's no need for me to see it in the results window. Also at the very end, I have a percent put statement. Cool little statement. It allows me to see the value of a macro variable. AVG is a macro variable. And if I'm telling Sass, please print the value of a macro variable, I need to precede that macro variable with the symbol amper. The query is executed, and in the log, I'm going to see the value 2.25. Quite nice, but still missing something because in the log, I have row numbers, and this 2.25 somehow gets lost in the sea of numbers. I like to see it preceded by the name of the macro variable. And how do I do this? By a little tweak to that percent put statement. I'll still have percent put, and then I'll say amper equals, by now Sass is expecting that I'm requesting a macro variable. And then after that, I give the name of the macro variable. So what this produces for me in the log is something you might be happier with. AVG heat equals 2.25. Very clear, very articulate, and there's no confusion. Let's head back to code. So we have a macro variable now, and we want to use it. We have AVG heat, and we know it's holding the value of 2.25. How do I use it in code? I'm going to use it in 2 separate spaces, and that really is the value of a macro variable. Reduce, reuse, recycle. What are the 2 places I can use it in? In the title statement, I can ask Sass to print the value of this macro variable AVG heat. And a rule that the macro language has goes something like this. If the original code, the title statement, is using a macro, and if the original code is using quotations, and you have a macro in there, then replace the quotations with double quotations. Same principle in the word clause. Is the original code heat scale numeric? I would have actually typed in less than 2.25. There are no quotations in the original code, so my macro is typed as is, no quotations. With this tab, I've macroized this query, and I'm going to see that value of 2.25 appear in 2 places. One in the title, second in the word clause, filtering only those rows where the average is less than 2.25. So this is the first form of storing a query in a macro value. Up until now, we've only seen a single value. Let's take it to real-time business where you have multiple values. There are 3 forms of the syntax of the into clause. Up until now, we've been seeing the first form. Let's see the first form in another business scenario. I'd like to see all the recipe names where the heat scale is less than or equal to 3. So I'm going to store recipe name into a macro variable, and I'm going to run this query and also check out the value of this macro variable. When the query runs, I get 6 rows of data. Remember earlier we had said keep that number 6 in mind. 6 rows of data where the heat scale is less than or equal to 3. All right. And the first row, let's pay attention to the first row, chana masala. Go to the log. The macro variable low heat recipe has only grabbed the first row of data and held it there. So this form of The into clause is syntax 1. It's only going to store the first row in a macro. By now you're probably thinking, I have 6 rows, I want 6 macro variables, not 1. We are here to solve that question as well. To store multiple rows in multiple macro variables, I'll still have my select statement, I'll still have my into and then the colon, followed by the name of the first macro variable, hyphen colon, the name of the last macro variable. So you get the idea. I'm going to create 6 macro variables. 6 rows of data are going to be stored in 6 variables, and I have a no print option turned on this time. Only the log with the %put statement will provide the values of the 6 macro variables. So this is syntax 2, that is storing multiple rows in multiple macro variables. We have one last syntax, this is syntax 3. Syntax 3 is going to store a list of values. So say I want to get to know all the recipe names where the heat scale is less than or equal to 3, so that I can pass it to a where clause to the chef table and get to know who the chefs are and the country of origin for these dishes. Let's begin first by storing the list in a macro variable. Once again, the syntax is very similar. I still have the no print option turned on. I have a select. I give the column name that I want to store in a macro variable. And then the into clause at the colon provides the name of the macro variable, nothing new here. And then I give this separated by. In quotations, I give the comma and the space. So I'm going to end up with a list of values separated by commas. Let's take a look at what this will hold in the log. Right in the log, I'm seeing the data values. Each of the rows of data is being stored in low heat dish, and the data values are separated by a comma. Well, that's pretty good. Can I now use a where clause and get to know who the chefs are? I certainly can. I have a standard query where I am grabbing data from dinner.chef, where name of the dish is one of a list. Remember earlier we said, if my existing code uses quotations and I want to sub that with a macro, then I need to use double quotations. So I think I've respected all the naming rules, all the logical rules, and I will now proceed to submit this code. Surprise, surprise, no results. Well, the next best place is to check the log. No rows were selected. This is a problem. Let's go back to the code and let's validate. Do I really have anything in low heat dish? And yes, the macro variable has all the recipe names stored in there. However, this query did not run. And that's basically because when I pass a list of values to a character column for comparison purposes using the in operator, I need to specify each character data value embedded internally with quotes. So in the log, each of these values needs to be embedded with quotations. So in order to take care of that, I give you another cool option. This is the format equals option. So this is going to embed each of the data values stored in low heat dish for heat scale less than or equal to 3 with quotations. Let's check it out, and let's also put the value in the log. And here we go. Each of the data values is now embedded in quotations. Why the code 40? Well, I tried to see the largest value of my data and specify it accordingly. Now it's a piece of cake. Now I can just say, well, because each of my data values is already enclosed in quotations, I don't need to give another quotation here. I'll submit this query, and this time everything should be the way I wanted it to be. I know all the chefs that have a recipe that has a heat rating less than what I wanted. What a fun way to take information that's scattered and combine it into a report using the power of SQL for an everyday action like cooking. I hope you'll give it a try. I hope you will try the macro language and really marry the power of two languages, the power of SAS SQL and the macro language, to give you exactly the results you desire. I personally believe that knowing SQL is one of the most important skills for data workers. Now I'm going to turn it over to you. What technique are you going to try first? Give a comment or subscribe to our channel. Thanks for watching.